So what is a fraction? This is going to be a hugely important video for being successful in this class, because I know that for a lot of you, you're a little bit scared of fractions. Some of you will even claim you hate fractions, and some of you would like to never ever see a fraction again. If you are one of those people, or anything similar to those statements, disliking, fearing, being afraid of them, being confused by them, mad at them, any of those things, this video is for you. So, in order to do anything with fractions, in order to get over your fear or your dislike, you need to understand what a fraction is. So some of these questions on the surface might seem very basic, but I really want you to get to an understanding of what is a fraction. If you put in the time and effort needed to completely master the ideas in this video, you will become successful using fractions. Now, I know I sound a little bit like a salesperson, but in my teaching experience, this is it. This is the foundation. If you truly understand this, then you can reason your way through anything else that we do with fractions. I want complete understanding. No, I'm not kidding. And yes, I truly believe that you can do it. Absolutely. Some of you are going to have to get over a bit of a mind block. Some of you are going to have to get past your insecurities about fractions. But if you truly understand what a fraction is, it will take you a long way in this course. So here's your first question. What is the area of shape A? So I want you to pause this video. I want you to look at this picture, and I want you to really think about what is the area of shape A. Okay, hopefully you have a guess down. Maybe you have several guesses down. Doing an exercise like this in class, these are sort of some common answers that I sometimes get. Some people will say that A is a fourth. Some might say A is a half. Some might say A is an eighth. And some might say A is a 16th. Now, we're going to come back to this problem later, and if you don't have one of these four answers, but you have something else, and it's not addressed in this slide or show or in this video, please contact me. I would be happy to talk to you about your answer and whether or not it's going to make sense, because here is going to be my solution to this problem. All of these answers are correct. What? I know, you're used to math problems where there's a certain way to do something and there's one right answer at the end. I am saying in this particular problem, any of these four answers would be correct. Now, before we get to that place, we need to figure out sort of what this notation means. What does it mean to be 1/4? What does it mean to be 1/2, 1/8, or 1/16? So let's start with 1/2. That's the easiest fraction for most of us. We're very comfortable with 1/2. So now I'm asking you, what is a half? How would you answer this question? If someone came up to you and said, I don't understand, what is a half? What would you say? So seriously, pause this video, think about what your response would be, and try to be a little bit more than a half is a half. Okay, maybe you're comfortable with your answer to that question. Maybe you're not. Well, let's go to the next step, especially if you're not. Okay, so try this. Which of the following pictures appears to show 1/2? Now, most of you can glance at this and very quickly say which ones have 1/2 and which ones are not 1/2. So of the ones that are not, why are they not 1/2? So the first square appears to show 1/2. The circle, on the other hand, is not 1/2 because the pieces are not equal. This piece is larger than this piece over here. So clearly that's not 1/2. Then the first triangle represents 1/2. And the second triangle does not represent 1/2, similar to the circle. That little shape on the top is definitely smaller than the larger shape on the bottom. Now, the last rectangle, it also isn't 1/2 because now we're only talking about one of the three pieces. So now I have three pieces in there. So it is definitely smaller than 1/2. Okay. So another leading question, why is it a 1 and a 2 in 1/2? So the 1 is coming from the fact that there's only one piece in each of these shapes that's shaded blue. So there's only one piece. And there are two pieces in the shape. Now, we're talking about the ones that represent a half. So we're talking about this shape and we're talking about this shape. The reason that they represent 1/2 or appear to represent 1/2 is that one piece is shaded and there are two equal pieces inside of that shape. So let's generalize that. So we're going to say that 1 is the number of pieces selected, because sometimes we're going to shade it, sometimes we're going to do other things. 2 is the number of pieces in a whole. So we may not be talking about a shape, we might be talking about something else, so let's use the word whole. So let's go back to the answer me this. So this is A. So let's talk about why the area of A could be 1/4. Let's go back to what we just talked about. So 1 is the number of pieces selected, and 4 would then need to be the number of pieces in the whole. So if I redraw it like this, if I treat that blue rectangle as the whole, I can see that A fits inside of that blue rectangle exactly 4 times. So this is the A that I'm originally asking about, but 1, 2, 3, 4 A's fit inside the whole if the whole is the blue rectangle. Now 1/2. So back to our original A, that's the shape we're talking about. Now, if I put another A next to that, and I treated that bigger green rectangle, or if I go around the outside with blue, if I talk about this square that's blue, then half of that square is the original A. Because now I have 1 selected, that's my original A, and then I have 2 equal pieces in the whole. So if I count this blue square as my whole, as my 1, then A is half of that blue square. So thinking about the 1/4 and the 1/2, how could I get an answer of 1/8? Well, if now I find an area that has 8 A's, like this, now I can see that there are 8 A's inside of the big square. So again, looking at the blue square, now it's a bigger one, the original A, this was the original A I was talking about, that represents 1/8 of that larger square. So if my whole, or if my area of 1 is that large square, then my original shape A is 1/8, because A fits inside that shape exactly 8 times. So what about 16? So now I'm talking about 1/16, but I just showed that only 8 A's fit inside this shape. So I would need a shape where there were 16 pieces inside. So that might look something like this. If the blue rectangle represents my whole, then my original A would be 1/16 of that. I would have one shaded piece and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces in the whole. Now, I know this one looks a little bit more confusing because what's happening now is the original square, this one, right, is actually half of the whole. So what you were doing is you were only shown half of the whole, and then the A that was given would be 1/16, if that were the case. So hopefully you're noticing as we go through this that what you take a fraction of is so important, right? Not only did I just show you 4 possible answers for exactly the same shape, there are more. There are tons more. It all depends on what the whole is, what you are taking a fraction of. So think of this example. If I walked up to you today and said, hey, today is your lucky day, I'm going to give you 2/3. Would that actually be your lucky day? Would you cheer and say, yay, thank you so much? Or would you say, yeah, no, I don't think so. Hopefully the first thing you're going to say to me is 2/3 of what? And if it's 2/3 of my recent huge inheritance, yay, we're happy, lucky day. If it's 2/3 of the trash in my neighbor's trash can, yeah, no thanks, right? So what you are taking a fraction of is very, very important. Right? So hopefully you've noticed that I keep talking about the whole, and I keep talking about the number of pieces in a whole. I don't say the total number of pieces, okay? And I don't just say pieces, right? So for example, I don't say that 3/4 is 3 pieces out of 4 total pieces, or 3 pieces out of 4 pieces, even though these aren't necessarily wrong. I say 3/4 is 3 pieces selected with 4 pieces in a whole. Why am I so picky about that? 2 main reasons for this. 1, knowing what the whole is very important for fractions. You need to know what you're taking a fraction of. And 2, saying out of is problematic with fractions like 7/3. That would sound something like, this is 7 pieces out of 3 pieces. Well, that doesn't make any sense. How can I have 7 pieces out of 3 pieces? So I switch that to 7 pieces selected, 3 pieces in a whole. Then there's no limit on how many pieces I can have. So 7 pieces, 3 pieces in a whole just means I have more than a whole, right? So if I'm sitting down to eat some pizzas, and they're smaller pizzas and there's only 3 pieces per pizza, I can still eat 7 pieces of pizza. Okay, so definition of a fraction, I've already said this, I'm just putting it on a single side so you have it right there. And I will tell you this, and I will rarely tell you this in this class, you need to memorize this. A fraction is the number of pieces selected divided by or over the number of pieces in a whole. Not the total number of pieces, the number of pieces in a whole. The other key part is that every piece must be equal in size. Now, the way that's defined might be dependent on the problem, okay? But every piece needs to be equal in size. It needs to be worth the same amount. Okay, so let's do a couple fractions in context. Okay, so after a quick check, I logged in, I checked it out. 26/44 of the class worked on their web work assignment last night. What does this mean? Use the definition. The number of pieces selected over the number of pieces in a whole. So, what do we need to know? What is selected in this context, right? We've provided a context now, so instead of using this generic word selected, let's narrow it down. So what is selected? What are we talking about? Well, we're talking about the students who worked on their web work assignment. Secondly, what is the whole in this context, right? So of that group selected, they must be a part of or related to the whole of this context. So what's the whole here? The entire class, right? 26/44 of the class worked on their web work assignment last night. So who are we talking about? We looked at the class. Within that class, we were talking about people who worked on their web work assignment. So how would we word this? So there are 44 students in the class, 26 of them worked on the web work assignment last night. Now, how you write that last sentence is not really important as long as you have the two ideas that there are 44 students in the class and 26 worked on web work last night. Another context. So there was a recent poll, 57,800 of voters plan to vote for Jalen. What does this mean? Again, we'll use the definition. The number of pieces selected over the number of pieces in a whole. So what's selected in this context? Who are we talking about? What are we referring to with this fraction? Well, we're looking at the people who plan to vote for Jalen. Right? And what's the whole in this context? Those people in relation to the whole. So the whole in this case, voters. Now be careful. This specifically says that we're finding a fraction of voters. It's not the population. It's not the adults. It's not everyone over age 18. It specifically is the voters. So if we wanted to rewrite this is telling us that 802 voters and 57 of them plan to vote for Jalen. Okay, so what if I went back to this polling question and instead of having a number like 57,802, let's say that in a recent poll, 2/5 of voters plan to vote for Jalen. What does that mean? Well, using what we just said, that would be something like 5 voters with 2 planning to vote for Jalen. Now, chances are this is in a town or a city where there are more than just 5 voters. So what does it mean when there's 2/5, but there's actually more than 5 voters? Well, what this means is that for every 5 voters, 2 of them plan to vote for Jalen. So out of the group of voters, if you just happened to come across 5 of them, right, this data shows that 2 of those would vote for Jalen. And then if you took the next group of 5, right, sort of on average, we would expect 2 of them would vote for Jalen. So you could scale this up to a much larger town. So just because it says 2/5 doesn't mean that 5 is the absolute number in the whole. Okay, we could have been sort of scaling this down and saying they're not exactly 5 people, but for every 5 people, 2 of them are voting for Jalen. Okay, so some pretty big ideas. So here's the summary. Pound these in your head. Talking about fractions, we're talking about equal pieces. Think about sitting at a table with some kids and you bring out this delicious cookie or brownie or pizza or something they all want, and then you try to split it up, right? Well, in order for it to be fair and for order for those kids not to whine and complain about how they didn't get enough, you got to have equal pieces. Second, you need to understand what the whole is. In context, there might be some words to tell you what it is. In a drawing, they need to tell you what it is, or you need to designate what it is. Sometimes what the whole is will be obvious, and sometimes it will not. But you need to know what you are taking a fraction of. Third, a fraction is the number of pieces selected divided by the number of pieces in a whole. And fourth, let's really try to break through that fear or hatred of fractions. Okay, let's try to give ourselves a chance to really learn this, to really understand it, to become a little bit more comfortable with fractions. Now, I'm not saying you need to love fractions. I'm not saying you're going to use fractions all the time, everywhere, but at least get over that initial hump of, oh my gosh, there's a fraction in this question. I definitely can't do it.